Hello everyone, my name is Ezra Kenig. I'm a last year engineering student at NSAT in Lannion in computer science and electronics. And today I will present you my contribution to a project that started in March of this year and that I contributed during an internship. This internship consisted in implementing and integrating an object detection algorithm onto the ONE-PIX kit. First, I will present chosen method that we selected, called SPOD for single pixel object detection. Next, I will briefly describe the implementation of the method. Then I will present the results that we obtained for the moment and finally conclude on the perspectives of the project. So the SPOD method is a deep learning based object detection method that is specifically designed for single pixel images. Object detection is a computer vision problematic that consists of predicting a scene's objects and their position. So you see at the bottom that based on an image, the algorithm is supposed to give us the coordinates of the object and its nature. So, for example, on this image, a dog and a sheep with their respective bounding boxes. And it is a method that is specifically designed to work for single pixel cameras because it doesn't necessitate to capture an image to work. It works directly on the imager measures. So that's what we see on this slide. In use case, we perform a classic measurement using optimized and localized patterns onto the scene. And those measurements are passed in a convolutional decoder that is responsible, that has to reconstruct the image, and a backbone network will do the object detection part based on the reconstruction of the scene performed by the convolutional decoder. To implement the method, we have to go through two-step training. So in the first training step, we train convolutional encoder and decoder. The first one to form a compression of the image that is supposed to be decoded by the convolutional decoder. The main goal of the convolutional encoder is that during the training, it will optimize some convolutional kernels that will be used as the projection kernel during the measurement performed during the SPOD use case. So during the second training phase, we just add the backbone network right after the reconstructed image, and we let the convolutional encoder and decoder still adapt during this training phase to get the most optimized result. As I said, once the training is done, we can extract the optimized convolutional kernels that were formed into the convolutional encoder. We then apply a zero padding process onto those extracted kernels so that we form 16 projection patterns for each kernel, where the original kernel is located on 1 square of a 4x4 grid. This is done in a way to reproduce the convolutional operation performed by the convolutional encoder that is removed during the SPOD's use case. For the results, you can see on the left some reconstructed image that we obtained in simulation. You can see that you can recognize the object present on the image, although the quality is not comparable. And on the right, you can see the horse example with what we added is the reconstructed image using ONE-PIX measurements. And what you can see is that the simulated reconstruction and the real case reconstruction are not similar at all. And that is what the project is currently at. We are currently working on making the simulated and real reconstruction similar. So for the project perspective, what has been done is the programming of the network's architecture and training routines. We also implemented the patterns extraction and creation process onto the ONE-PIX. And like I said, what is currently ongoing is obtaining the same reconstruction results in simulation and in real use case. And in near or far future, what could be done to improve this project is obtaining a performance detection model and also creating a data set fitted for POPs application. So, for example, a data set that could help us perform plant phenotyping or crop supervision, for example. And lastly, all the work that has been done for SPOD has been with grayscale images, which do not exploit the hyperspectral aspect of the ONE-PIX kits. And this aspect could be very helpful in improving the model's predictions. Thank you for your attention. If you have any question, I will be happy to answer them.